For number 14, we're asked to write this in factored form and make sure it's factored completely. So going down my list, I'm going to check for GCF first. Is there a number that divides 5, 35, and 60? In fact, there is 5. And do they share any x's? No, because this last number here, the 60, does not have an x. So GCF worked here. Pulling out a 5, so distributing backwards, 5 times what gets us back to 5x squared? Well, x squared. Bring down the plus sign. 5 times what gets us back to 35x? 7x. Bring down the plus sign. And then 5 times what gets us back to 60? 12. Whenever you factor by GCF, you need to always check what's left in the parentheses because you could possibly use either method 2 or 3 next. Method 2 fails because in the parentheses there's 3 terms. So let's check for method 3. It is a trinomial. This would be the easy factoring method, building the x, where you're looking for what multiplies to the back number 12 and adds to the middle number 7. And again, you're ignoring the 5 here in front because that already got pulled out. So is there a factor pair of 12 that adds to 7? Making a factor list if you need it. 1 times 12, that does not work. 2 and 6 does not work, but 3 and 4 do. So we do have a factor pair, 3 and 4, and both of these will be positive to make a positive 12 and a positive 7. So this can split up as x squared splits as x times x, and then we're filling in a positive 3 and a positive 4, and the 5 does not disappear in our answer. It is still brought out in front from the very beginning because you pulled out a GCF here. By the way, you could have used method 3 from the start, where you would multiply the first and last number and make a factor list of 5 times 60, 300, and figure out what multiplies to 300 and combines to 35. You get the same answer.